Hello everyone, good afternoon everyone. So today we will be discussing nucleophilic substitution reactions. Okay, so in the last session we have covered GOC, and then next we have covered hydrocarbons, then also we have covered haloalkenes, haloarenes, all these things, right? Okay, so today we will be mainly focusing on nucleophilic substitution reactions. Okay, so from this particular topic, see, from reaction mechanism, so you need to focus more on either one thing is nucleophilic substitution reaction, the next elimination reactions, and the next aromatic electrophilic substitution reactions and aromatic nucleophilic substitution reaction, all these things. Okay, so in the last class I have explained aromatic electrophilic substitution reactions and as well as aromatic nucleophilic substitution reactions, and the next I explained benzene mechanism also. Okay, so I just want to discuss a special special focus on this nucleophilic substitution reactions, because they may ask questions from this using this mechanism. They can create questions from haloalkanes and also alcohols and also from phenols, so also from ethers. So these are the topics they can interlink with this mechanism and they can give as a question in the exams. So from this particular session, so you are going to get some confidence that whatever the question, from wherever it is coming from, if it includes this reaction mechanism, this nucleophilic substitution reaction mechanism is included, then you are going to attempt that question for sure. So this is how we are going to understand this topic now. So kindly focus here and listen to the class. Okay, so just give a minute. I just want to confirm whether everything is clear or not. Yeah, so now, so what exactly nucleophilic substitution reactions here is? So nucleophilic substitution reactions. So we know in chemical reactions we will be having something like reactants and products. So this reactant side we will be writing something like substrate and some reagent, and finally this this reagent, attacking reagent may attack on the substrate, and this results to form something called what? Transition state or intermediate. So I'm beginning this topic from very basic, so try to follow this at most patience. Okay, intermediate, or we can also call so we can also see sometimes transition state will be observed sometimes in some reactions. Okay, and finally give some products plus some byproducts will be formed, right? Okay, so now here nucleophilic substitution reactions, what does it mean? See, the name itself saying that nucleophile substitution taking place. So it means, let us say our substrate is having something like this. So some alkyl group I am indicating like R. Okay, so this R indicates what? Alkyl group attached with some group L. So L is a group which is having relatively more electronegative than this R. Okay, it means alkyl group. Okay, so this L, let us say, called as leaving group, and our reagent I am representing with Nu, because Nu minus, because it is a nucleophilic substitution. Now this nucleophile will substitute this R like this L group from this R, alkyl group. So this will attack here and this will goes out. See, L, the group L is substituted by this nucleophile group. This is incoming nucleophile, this is leaving group or outgoing nucleophile we should say. So this group is substituted by this incoming nucleophile, right? So this is what happens in the nucleophilic substitution reaction. So something like when we are playing a game, one player will be substituted by other player, no? So here also one group is substituted by other group, one group is replaced by other group. This is what happens in the substitution reactions. So in this substitution reactions, nucleophile like negative charge species is involving now, so that's why we are calling them as nucleophile, and the process is called a nucleophilic substitution reaction. I hope it is clear. So what is the product we can expect here? RNU, like this, means nucleophile are replaced in the place of this group L, substituted in the place of L. Okay, so this is what the process happens. So here we have substrates and this is what? Final product, right? Okay, so during this process we may expect to have something called intermediate, sometimes intermediate, or in some reactions we may have transition state. Okay, either intermediate or transition state is there, finally that will be giving product like this. Okay, so now these nucleophilic substitution reaction, these nucleophilic substitution reactions are of two types. What I am saying, these nucleophilic substitution reactions are two types. Those are unimolecular nucleophilic substitution reaction. So in the short form we can call it as SN1. Okay, and one more is bimolecular nucleophilic substitution reaction, that is SN2. Depending upon the molecularity or depending upon the number of molecules involving in the rate determining step, reactions are of two types. One is SN1 and another one is SN2. So we need to understand these two reactions now. Okay, so nucleophilic substitution reaction means what happens, one nucleophile is replaced by another nucleophile. Yes, this is what happens here. Okay, now these substitution reactions is of how many types? Two types. One is SN1, other one is SN2. Okay, let us study this SN1 and SN2. Okay, let us start our discussion with SN1 reaction. So here substitution, what exactly mean by SN1? Look here, substitution, S represents substitution, N represents nucleophilic, 1 represents unimolecular. So substitution nucleophilic unimolecular, that is what SN1 reaction. Okay, so in these reactions what happens, look here. So let us say I have an alkyl group R. Okay, this is attached with some group X or L. Let us consider X, which is halogen or one living group you can say. Okay, let us say X is a halogen here. Okay, now what happens is, see, when we kept this substrate, when we keep this substrate in the solvent, what happens is this bond get ionized. It means it will be polarized depending upon the electronegativity difference. I told you this is something, let us take halogen, which means halogens will be having more electronegativity than this alkyl group carbons, right? Therefore, this bond will be polarized like this and creates some charges, and it will dissociates like, it will polarizes like R plus, and the next we will be having X minus, right? Okay, so this R plus is nothing but what it is? It is not what? It is a carbocation. R is nothing but alkyl group attached with halogen. So I can say R group as carbocation. So this carbocation is intermediate in this process. In SN1 reaction, what is the intermediate form? Carbocation. I hope it is clear up to here. Okay, so to this carbocation, a nucleophile will be attacks. Okay, this nucleophile will be attacks on this carbocation and finally gives some product like this RNU. Okay, so I will be taking one general common example after this, but this is how we can generalize the reaction. Okay, this is what the process happens here. Okay, so conversion of substrate to product includes an intermediate stage, right? Okay, so this process having two steps. How many steps? From substrate to this carbocation intermediate, that is one step, and this is relatively slowest step or slow step. Okay, now during a reaction, the slowest step is considered as rate determining step. What I am saying, the slowest step involved in a particular chemical reaction is considered as rate determining step. So in this process, I told you this is slow step and this is fast step. Okay, so now the relatively slower step, this is the slower step now. So this slowest step is considered as rate determining step. In the short form we can say RDS step. So carbocation intermediate formation is a rate determining step in SN1 reaction. I hope it is clear. Okay, now what you need to understand here, so rate of this reaction. So rate of this reaction, it depending upon what? See, rate of reaction, rate determining step is this formation of carbocation. No? So rate of reaction depending only on this whatever the substrate we are taking, but not on the nucleophile. So rate is directly proportional to concentration of substrate I have mentioned here. So you can write rate of reaction is directly proportional to concentration of substrate only, concentration of substrate, but not on the nucleophile. Okay, this is what you need to understand here. Okay, this is what kinetics explains us, reaction kinetics. Okay, now now the substrate involved here is this alkyl halide na? So the concentration of that substrate is taken, so order of this process will be 1. So we can say order for this reaction, it is only depends upon concentration, substrate concentration, so order of reaction is 1. Okay, this is what you need to say. I hope it is also clear. Okay, now we have different alkyl halides, right? For example, primary alkyl halide we can have, secondary, tertiary, like that. For example, here I am taking, CH3, CH2, Br. This one I am taking, and the next CH3, Br. Okay, and one more I am taking, CH3, here also CH3, here I am taking Br. So out of these three alkyl halides, which will react relatively fast, shows faster reaction. So which of these, under what is the reactivity order towards SN1 reaction, which will having faster rate of reaction. So write the rate of reaction towards SN1 if they ask like this. How can we answer this kind of question? So in order to understand this, look at the mechanism, this basic mechanism whichever I have represented over here. See here, formation of carbocation is rate determining step, right? So what I am saying, formation of carbocation is rate determining step. Out of this, see, if this halide ion is removed out, or if this halide ion is removed out, so when we are keeping this substrate in the solution, in the solvent, what happens in the solvent? The ionization takes place now, like this polarization takes place, and the substrate one which is giving more stable carbocation, that process will be taking faster. See here, it is giving a, if this polarization happens, it will be resulting to form a primary carbocation like this, and this will be giving us secondary carbocation like this, right? Okay, see guys, just hold for some time. So just listen to me very carefully for some time. After that I will show you how easily you are going to solve the questions. So please focus on the class for few more minutes. Okay, after that you can ask whatever the question or whatever the doubts, difficulties you have. Okay, now if this bond broken like this, so what happens? So here we are getting a carbocation like this now. So which carbocation is more stable here? We know tertiary carbocation is more stable. It will be stabilized by this alpha hydrogens by 9 times by hyperconjugation. And here it is secondary, here it is primary. So which carbocation is more stable? We know tertiary carbocation is more stable than this secondary and this primary. Therefore, the polarization or this ionization, the formation of carbocation is readily takes place when it is tertiary alkyl halide. Therefore, this will involve in this SN1 reaction most easily or more readily. So the rate of reaction for this 3 alkyl halides will be tertiary more than secondary more than primary. This is what you need to understand. So I can write here generalizing that tertiary alkyl group containing alkyl halides, alcohols are more reactive than this secondary alkyl halides or alcohols, and the next primary alcohols or alkyl halides. Okay, then this methyl halides. So this is what you need to understand here. So this is what the rate of reaction. Okay, now I told you one thing. What I told you, we need to keep the substrate in the solvent medium. Therefore that solvent will polarize this substrate into cationic form and anionic form depending upon their electronegativity differences. So for this process, the solvent used for this polarization process is polar protic solvent. Which solvent will favors for SN1 reaction? That is polar protic solvent. Okay, so polar, the bond, the molecule should be that whatever the solvent molecule we are taking, that should be polar solvent. Okay, what are the examples for polar solvents we have? Like water, alcohols, these things. Okay, and what about protic solvent? So protic, aprotic, polar, non-polar, these are the terms we need to get some clarity. When I am saying polar, the molecule should be having some polarity. Okay, if there is no polarity, if there is no difference in polarity, so we can consider it as non-polar. So here, for example, here we can take what? Water, and the next alcohols. Okay, these things we can consider here. And when I am saying protic and aprotic solvents, okay, when I am saying protic solvent, it should be forming hydrogen bond. That solvent should form hydrogen bond, especially that solvent should have hydrogen bond donors. Donor side, hydrogen bond donor side should be there. So it should show some hydrogen bond donor nature. What does it mean by hydrogen bond donor nature? Means, for example, water molecule, if I consider here, see here, this molecule, water molecule, we know that water molecule will show hydrogen bond. So what kind of hydrogen bond it can form? See, due to the electronegativity difference between hydrogen and oxygen, so hydrogen will be having partial positive charge, and oxygen will be having partial negative charge, right? Now this hydrogen can form hydrogen bond with the other oxygen molecules like this, or other electronegative atom. Okay, so that is what, see, it is donating hydrogen to form a hydrogen bond with other molecules. Now this molecule providing hydrogen atom to form a bond with other molecules. So that is what? Hydrogen bond donor. Now here oxygen having lone pair electrons. Now using that, this oxygen can also accept one hydrogen bond. It means using that lone pairs, oxygen can form a hydrogen bond with the other hydrogen atoms of other molecules. So that is what? Hydrogen bond acceptor. So this, if it is providing hydrogen to form a hydrogen bond, we can call it as hydrogen bond donor. So solvents which are polar and also which are protic solvents, those are what? Polar protic solvent favors SN1 reaction. I hope it is clear. Okay, so I hope what exactly mean by protic also clear. So it should form hydrogen bond, especially that should be act as hydrogen bond donor, then we can consider protic solvent. Okay, aprotic solvent means it will not form hydrogen bonds, or it will not show it will not have hydrogen bond donor sites. Okay, so these are the examples you can understand. See, I will give you one more example. Now here you can see ROH I am writing. Now it can donate, see, this bond can polarize H plus OH minus, right? So now this hydrogen can be forms hydrogen bond with the other molecules, other electronegative atoms. So I can say this is ROH, alcohol is hydrogen bond donor, I can say. Now let us consider acetone. Acetone, look here, there is no hydrogen atom attached to the any of this electronegative atom. So there is no hydrogen bond like hydrogen bond donor sites. I mean, there is no hydrogen atom to donate to the formation of hydrogen bonding in acetone. So this cannot act as hydrogen bond donor, but it can only act as hydrogen bond acceptor using this lone pairs. So acetone is like I can say acetone will be aprotic solvent. What I am saying, acetone is aprotic solvent and it is having polarity like this. So I can say acetone is polar aprotic, whereas water molecule, alcohol molecules are polar protic. I hope the difference you got, what exactly polar aprotic, polar protic. Okay, so SN1 reaction is favored in the solvent which is polar protic solvents favors SN1 reaction. I hope it is clear, there is no confusion. Okay, so why I have spent this much time to explain this is that is very important when it comes to solvent effect in like deciding whether the reaction follows SN1 mechanism or SN2 mechanism. I hope it is clear. Now till now I have only covered very basic things. So let us move little more deeper, so that will gives you more clarity. Yes. See guys, one more thing, whatever the exam you are going to write now, mean whether it is NEET or upcoming NEET exam or upcoming EAPCET exam or the other JEE Mains Advanced, whatever the exam you are going to write. So whatever I am explaining here, that will be definitely gives you some like clear cut idea on SN1 and SN2 reactions. Okay, so you can trust on that, so you can follow the class very carefully. Here once again look, this is a substrate. Here I have mentioned what I mentioned here, generalized alkyl halide na. So which alkyl halide is more reactive in SN1? Tertiary, then secondary, then primary. Why? Because we required a stable intermediate formation, right? So during this process, the first step is what? Formation of carbocation, which is intermediate. So if stable intermediate is formed, that favors a forward reaction. So when we get more stable intermediate, more stable carbocation, if it is tertiary alkyl halides or tertiary alcohols, will give us more stable intermediate carbocation. That's why 3-degree alkyl halides are more reactive or more favor SN1 reaction. Okay, so here I have taken a tertiary alkyl halide. Look here, so this is a tertiary alkyl bromide. Okay, so to this tertiary alkyl bromide, okay, when we are keeping in the polar protic solvent, let us say we kept this in the water. What I am saying, we kept this in the water. Okay, so water is a aqueous medium, is a polar protic solvent. Okay, now what happens, this bond polarization takes place. See here, Br is there, carbon is there. So this bond polarization takes place. This bond polarization takes place like this. Okay, and resulting to form Br minus and carbon with positive charge, we can say carbocation. So we know for carbocation will be having this carbocation will be having what? We have one empty orbital here. The carbon is now sp2 hybridized. What is hybridization? sp2 hybridization, carbon is there at the center. So this is having trigonal planar geometry. What geometry it will be having? Trigonal planar. See, within the plane that cation will be at the center and 3 groups are there surrounding it. Okay, now what happens, this is what? Slow step or RDS step, rate determining step. Okay, now the incoming nucleophile will be there na. So this OH minus, let us say this reaction is like tertiary alkyl bromide. Okay, this is what I have mentioned is a tertiary alkyl bromide reacting with aqueous NaOH, like this they mention. Okay, so what is the product, they will ask like this. Okay, now what happens is, first of all, this carbocation intermediate formation takes place. On that, this OH minus attacks, this is a nucleophile. Aqueous NaOH means OH minus will be the strong nucleophile here. Okay, that OH minus will attack onto this carbocation. See, if this is the carbocation plane, so it can attack, OH minus can attack from above the plane or it can comes from the below the plane. So if it is coming from the above the plane, we will get one type of product, right? And if it is coming from the below the plane, we will get another type of product. For example, when it is coming from above the plane, so this is a trigonal planar, let us say in my hand. Okay, from above the plane, if this nucleophile is coming, we will be getting, let us consider a configuration, like we can consider it as R isomer. Okay, there are 2 types of isomers, one is R, another one is S isomer. So let us say this will be R isomers, if I say. Now the other will be S isomer. So both of them are having opposite configurations, right? So now the formation of R and S will be having 50-50 chances here. Generally we can say this is having 50-50 chances. Okay, sometimes, so it is also mentioned that, see, it means what? For example, our starting material is having R configuration, let us say R configuration. Okay, during this chemical process. So why I am saying this RS, what is this? See, here carbon is there, around the carbon we have 4 different groups, right? 4 different groups are there. So when a carbon is surrounded with 4 different groups, we can say it is chiral carbon. What is that? Chiral carbon. So it is optically active. What do we mean by optically active? When this compound, when this solution is taken, when we pass a light, that light is called plane polarized light. So that light will rotate, this solvent will rotate this light either clockwise or anti-clockwise depending upon its configuration. If R configuration containing compound rotating left side, then S will rotate right side. Okay, like that, or vice versa will be happening. I hope it is clear without any confusion. Okay, now if for example our substrate is having R configuration, okay, so from this during the reaction we may get R configuration product, or with opposite direction we may get S configuration product depending upon the attacking nature of this OH minus. So when reactant is having R, product is also having R, both configurations are same, we can say this is retention. What is that? Retention product. Okay, if R configuration a substrate is giving S configuration, it means R giving S or S giving R, opposite if it is giving, so we can say inversion product. Okay, so there are two types of products are possible in SN1 reaction. One is retention, another one is inversion. I hope it is also clear. Okay, now which is favored more here? Okay, so generally what I told you, 50% chances for R and S configuration from this intermediate carbocation, because intermediate carbocation will be having planar nature, no? I mean it will be having trigonal planarity, therefore above the plane will give one isomer, below the plane will give another isomer. So this is what you need to understand here, that's why I am repeating the same thing. Okay, now in few cases it is also mentioned that inversion isomer, this if it is having R, the S configuration isomer will be formed relatively less, relatively more quantity, little bit more quantity, like it is 49, it is 51% like that. So inversion product is relatively little more. Okay, but most of the cases 50-50 chances will be there. Okay, so now what you need to understand from this 50-50 chances, when R configuration is 50, S configuration is 50. Okay, so I am saying 50% R, 50% S. Okay, 50% R, 50% S. So this is called racemic mixture. What I am saying? Racemic mixture. So this is racemic mixture. So now this racemic mixture is optically inactive. Okay, what is this? This racemic mixture is optically inactive. I hope up to here it is clear. Why it is optically inactive, sir? You might get this doubt. See what I told you, if R configuration rotates plane polarizer light right side, S configuration will rotate left side. If these two solutions are having, this solution is having 50% R, 50% S, then the light will be rotated right, simultaneously it will be rotated left, therefore net rotation will be 0. Okay, I hope it is clear. Okay, so this is called external compensation. Due to that, racemic mixture is optically inactive. What is that? Racemic mixture is optically inactive. Okay, so we can say this process is racemization. If we get 50% each R and S opposite configuration isomers, we can say that process is what? Racemization. Okay, now in the exam, if they mention partial racemization happens in SN1 reaction, that is correct. If they haven't mentioned partial racemization, if they simply mention racemization happens, you can go with the racemization option. But if there is option like a partial racemization, you can choose that partial racemization only, because you should not get confused. Okay, I will show you one question where you make confused. Okay, where the question makes you feel confused, because I told you inversion is relatively little more than this inversion configuration product will be little more percentage than this retention configuration product. That makes the partial racemization. Okay, I will show you one question on that which gives you more clarity, no issues about that. Okay, here what are the points I told you? It is a two-step reaction. Yes, formation of carbocation is one step, then next attack of nucleophile on carbocation is second step. These are the two steps. So whenever the reaction is having more than one step, so I can say multi-step reaction or non-concerted reaction. Non-concerted. Okay, then next here this is non-concerted, it will take more than one step, so we can say multi-step reaction or non-concerted. So if there is any chance for carbocation stabilization, the rearrangement of carbocation takes place. Okay, you have to understand this. Rearrangement of carbocation takes place. I will show you one example. Next, attack of nucleophile on carbocation. Okay, that is fine. So rate depends upon the concentration of substrate only. Okay, carbocation is formed, rearrangement is commonly observed, racemic mixture is observed. Yes, when it is optically active, racemic mixture happens. Okay, this is what the alkyl group, I mean reactivity order I have explained already. Okay, now next, favored by polar protic solvent. This is also we discussed. Okay, this is just for your reference. Okay, I already explained all those things. So what are the steps involved? First, substrate, and there will be nucleophile. This nucleophile attacks on the substrate, and when it attacks first this polarization takes place and generation of carbocation. See, yeah. So first of all, this polarization happens, and see, like this, partial positive charge, negative charge is created where we have carbocation intermediate, right? So this process is there now. This is the slowest process, process having more activation energy. That's why we are saying this as rate determining step. Okay. So now here we have what? Carbocation intermediate formed. So to this, here we are attacking. This is attacking takes place and forms what? The final product will be formation takes place. So this is what the intermediate, this is substrate, intermediate, this is a product. So this is how you need to draw the energy profile diagram for this reaction. Which reaction? SN1. Okay. Then next, stereochemistry, everything I explained, just for your reference I have provided the information here. So this is what happens now. On sp2 carbon, from above the plane it can be attacked, or it can be attacked from below the plane of this carbocation. So it can give inversion product or retention product. 50-50 chances are there mostly, but sometimes inversion product is little more predominantly formed, and this can be 49% you can say. So I can say partial racemization happens here. Okay. Next, so what are the factors? How many factors are the substantial importance for the SN1 reaction? Yes, what are the factors here? Nature of solvent. Yes, we discussed about the nature of solvent. Yes, this is JEE question. So why I included JEE question? See, it's not about JEE or NEET or EAPCET. So it is completely we should get aware of the concept. Therefore, we can do any kind of question here. So when it comes to nature of solvent, the solvent is polar protic solvent favors SN1 reaction, I told you. Okay, if it is polar aprotic solvent, that favors SN2 reaction. You should understand that. Next, it depends upon the concentration of substance. Yes, rate of reaction I told you, it depends upon the concentration of substrate I told you, but not on the incoming nucleophile. So this is incorrect. Option 3 is incorrect because concentration of nucleophile is not affects the rate of this reaction. Next, nature of alkyl group in the substrate. Yes, if tertiary alkyl group is there, that is more reactive than secondary. We discussed this now, because tertiary alkyl group provides us more stable carbocation intermediate. That's why it is more reactive. Next, nature of nucleophile. Tell me, what is the nature of nucleophile? Is there any is there any impact of nature of nucleophile? No, right? Okay. Then next, what about nature of leaving group? Yes, leaving group ability. For example, I have on a particular tertiary alkyl halide, I have fluorine, I have tertiary alkyl halide with chlorine, I have tertiary alkyl halide with bromine, and tertiary iodide. So which reaction takes place? In which of these reaction takes place more easily? In which substrate it is easily? The leaving group ability is more for iodine. Therefore, iodide ion easily leaves out and formation of carbocation takes place easily in this process. Therefore, rate of SN1 will be more in alkyl iodides, then alkyl bromides, alkyl chlorides, like this. This is the order. Because this is a very weak leaving group, because there here carbon and fluorine having 2p orbitals now. So this orbital overlapping is very stronger, but here it is having very large size differences, which makes the bond to be broken easily. Therefore, gives tertiary carbocation very easily. That's why that involves a reaction more faster. So this is clear. This is also clear. This is also clear. This is also clear. So I can go with how many are there? 1, 2, 3, 4. 4 is a correct word or correct number of factors that is affecting the SN1 reaction. I hope it is clear. Next, in an SN1 reaction, chiral center is there. In an SN1 reaction, on chiral center, there is what happens? Yes, on chiral center what happens? Yes, see, this is a previous year question. I told you, Inversion is more than the retention, leading to partial racemization. 100% inversion or retention not correct. Okay, 100% racemization is there. So when there are two types like this kind of options, so I told you there is slight importance towards the inversion product, therefore partial racemization takes place. So you can go with option number 1. Okay. Now next, assertion reason questions here. So assertion is what? SN1, hydrolysis of optically active 2-bromo octane results in the formation of racemic mixture. Yes. Okay. Reaction proceeds through a planar carbocation which can be attacked by the nucleophile. Yes. So we know now. So they mentioned it as racemic mixture, racemization takes place. Yes. So here they mentioned optically active 2-bromo octane. Yes, 2-bromo octane is there. So upon that hydrolysis, like OH minus is a nucleophile here. Okay. So bromine is removed, therefore carbocation formation takes place. OH minus can come from above the plane or below the plane. Both chances are there, 50-50 chances. So it will be giving racemic mixture. Okay, this is correct because of carbocation intermediate. Both are correct and correct explanation. So I can go both are correct and R is the correct explanation of A. So option A is correct. See, this is EAPCET exam question. So it is not about which exam it is there, but you need to aware of all the concepts here. So because from SN1 there is no question paper without questions from this SN1, SN2, E1, E2 like this, from the reaction mechanism. Okay, so that's why I'm focusing very I just want to discuss with very in-depth concepts without leaving anything here. Okay, so now look here, choose the correct decreasing order of reactivity of alkyl halides towards SN1 reaction. So what happens here, which alkyl halides is more reactive? We already discussed tertiary alkyl halides are more reactive than the secondary. So tertiary, secondary, primary. So option C, very easy, right? Next, which of the following alkyl halides is most reactive towards SN1 mechanism? Yes, same question. So identify which is having see, all of them are tertiary alkyl halide, tertiary alkyl groups only, tertiary butyl group, but halogens are different. I told you the nature depends upon what? The living group ability of this nucleophile. I minus is good living group, I told you. Then next Br minus, then next Cl minus, next F minus. Why? What I told you the reason? The F and carbon is having almost similar sizes, therefore the bond will be relatively stronger. When it comes to iodine and carbon bond is relatively weaker, easy to break, and that will be polarizes easily in the polar protic solvent and forms carbocation very easily. Therefore option B is correct. If they ask for order, what you can write? B A D C. This is what the order you should write. Okay, so guys, this will be definitely helpful for your exam preparation. So even if you have any friends looking for proper reaction mechanism explanation or SN1 SN2 explanation, so please kindly try to share with them, that will be helpful for them also. Okay, the rate of reaction of tertiary butyl bromide and NaOH in water depends upon concentration of what? See, rate of reaction of tertiary butyl bromide. So this is tertiary, so in the short form I am writing tertiary butyl bromide. See, tertiary butyl bromide is nothing but like this. So we know if we remove this bromine, we will be getting a tertiary carbocation like this. So this is highly stable carbocation. It means it will follows what? SN1 mechanism. See, if it is having primary, see, tertiary, we know we have tertiary, secondary, primary and methyl halides, alkyl halides. No? So when it comes to SN1, tertiary favors SN1, then secondary, then primary. This is what the order for SN1. If they ask for SN2, take the reverse order. Like methyl will be favors SN2, then primary, then least is SN2 is least favored by tertiary. So whenever we have tertiary alkyl halide, go for SN1 reaction in polar protic solvent. Yes. Now in SN1 reaction rate depends only on the concentration of alkyl halide, that is substrate, but not on the incoming base or incoming nucleophile. So this, it will not depends on this OH minus, it depends only on concentration of what? Concentration of tertiary butyl bromide, but not on the incoming nucleophile are not on this both. Okay, only option D is correct. Which of the following will be most reactive towards SN1 reaction? So in order to show SN1 reaction, what we need to know, it should form a more stable carbocation. See, if we remove this, we will be getting a secondary carbocation. If we remove this, we will be getting a allylic carbocation. If we remove this, we will be getting a tertiary carbocation. If we remove this chlorine, it will ionize just like this. Now look here, this is tertiary, right? That is also stable and also allylic, like stabilized by this pi electrons, like this. So whenever there is something like this, like the pi bond which is in conjugative position, which is in alternate position with this positive charge, we can say allylic carbocation. Okay, that will be stabilized by this resonance. Okay, therefore it is more stabilized by resonance. Okay, and also one alkyl group from here and these two hydrogens, alpha hydrogens. 5 alpha hydrogens are there, 5 hyperconjugations are possible. So it will be more stabilized when we compare with the other options. So this carbocation, resulting carbocation from this substrate is more stable, therefore it will readily involve in SN1 reaction. So we can go with option D directly. I hope it is clear. Okay, then next bimolecular nucleophilic substitution reactions, that is what SN2 reactions. So just give me a minute. Yes, look here, now we are discussing about SN2 reaction. So in SN2, see here, I told you substitution nucleophilic bimolecular reaction. Okay, so or we can say bimolecular nucleophilic substitution reaction. Here also same, whatever we discussed there. So in SN1 reaction, what are the quick points we need to remember? It is having multi-step reaction. First is carbocation formation, which is slow step and rate determining step. Next step is attacking of nucleophile. So it is a non-concentrated reaction. So tertiary alkyl halides are more reactive than secondary, then primary, then methyl. Okay, then next what we discussed, rate of reaction only depends upon concentration of substrate. This is what discussed in the SN1 reaction, and polar protic solvents favors SN1 reaction we discussed. Here it is, let us say this is also alkyl halide, let us say. Now what happens here is we will be having a nucleophile here. So similar to that, here this attacking of this nucleophile and removal of this halide ion, the like leaving group goes and incoming nucleophile comes simultaneously. This process happens simultaneously like this. So we can expect R here, R is alkyl group, and see this leaving group is going out, this leaving group is going out, and incoming nucleophile is coming from the back side. See, X is this side, it is coming from back side attack. So like this. So both happen simultaneously like this. So this is not an intermediate state, we can call it as transition state. Transition state. Okay, transition state. Okay, finally it will be giving a product like RNU like this. Okay, now see nucleophile, like leaving group, this X is front side, here I mentioned nucleophile back side. It means the attacking takes place from the back side, you can understand like that. Okay, I will show you the proper stereochemistry, wait for some time. Here this complete process from reactant to product formation takes place in single step. So I can say this is concerted mechanism. It means single step reaction, concerted follows concerted mechanism, you can write, or single step reaction, single step reaction. Okay, you can write like this. And then next, it is favored by polar aprotic solvent. Polar aprotic solvent, I told you what exactly polar protic, polar aprotic. So here examples for a polar aprotic solvent, polar aprotic solvents are, so you can write acetone, and DMSO, dimethyl DMSO na. So dimethyl sulfoxide, like this. So this is also polar. See, this oxygen or sulfur bond get polarized, creating partial charges, and but there is no hydrogen bond donor site. Therefore I can say this is polar aprotic solvent. Like this is acetone, and this is DMSO, and we can also have DMF, dimethyl formamide. So these are what? Polar aprotic solvents, you can remember. Okay. Now one more thing we need to discuss here. So for polar, whenever I am saying polar solvents, they will be having high dielectric constant values. Okay, you can also remember like that. So for polar solvents, high dielectric constants will be there, or you can also remember they will be having polar bonds. Overall molecule will be polar. Okay, the dipole moment will not be equals to 0. If it is equals to 0, we are saying it as non-polar, na? Like hexane or benzene or CCl4, all these considered as non-polar solvents. Okay. I hope it is clear up to here, there is no confusion. Okay. So SN2 reaction is favored by polar aprotic solvent, single step reaction. Next, here in these alkyl halides, primary alkyl halide or primary alcohols also, this story applicable for alcohols, alkyl halides, whatever we discussed till now, it is applicable for all the reactions which have SN1 SN2 mechanism. Okay, like alcohols also shows this reaction mechanism, or alkyl halides also, and also ethers also, whatever it is, this concept is same here. So that's why I am generalizing this SN1 SN2 reaction to all these concepts. I will show you the reactions also. Okay, so this alkyl like primary alkyl halides, alcohols will be having more reaction than this secondary alcohols, alkyl halides, ethers. Okay, then next this tertiary, and this is more than this methyl halides, methyl alcohols, like that. I hope it is also clear. Why it is happens like this, I will explain you by showing you one diagram. Pictorial representation is required here. Okay, look here, see, this is the alkyl like carbon bromine bond. Okay, now see what I told you. See, there will be like alkyl halide, I told you, we have one nucleophile like Nu minus, let us say OH minus. Okay, so this will be attacks from the back side, I told you, and elimination of nucleophile like leaving group takes place. Okay, this happens simultaneously. I told you that the resulting will be transition state and forms the final product, I told you. Like look here, when it is this bond is getting broken, like incoming nucleophile is entering, right? But this is from exactly from the opposite side, right? Why it is not from the same side? Because see, let us say this is halogen having bromine, like lone pair electrons are there. So there will be repulsions between this incoming nucleophile electrons and this lone pair electrons. These repulsions, this fighting, these repulsions will not allow from same side entry, same side attack of this incoming nucleophile. So in order to avoid these repulsions, incoming nucleophile will comes from exactly from the opposite side. Therefore less repulsions are seen or no repulsions are seen depending upon the other groups. Okay, now that's why it is coming from the opposite plane. So like this, it will goes out, this OH minus is slowly coming in. So now here you can observe, how this transition state is appearing. So it is having trigonal bipyramidal geometry. Which geometry it is having? See, 3 bonds it is having, and here it is having 2 bonds. So we can say trigonal bipyramidal geometry it is having. In the short form I am writing TBP. But the hybridization of this center carbon in transition state is sp2. So these 2 points very important, many times it is asked in the exam. Okay, now I told you attacking from the back side now. So for example, this substrate is having configuration R. Okay, if it is optically active, how can we identify optical activity? If this carbon is chiral, how can we say this is chiral? If it is containing 4 different groups, yes, see, ethyl group, bromine, methyl, hydrogen, 4 different groups are there. So I can say that carbon is chiral. Okay, if it is chiral, now let us say if it is having R configuration, okay, whether RRS, keep aside, let us consider if it is having R, then our product will be having S configuration. What I am saying, product will be having S configuration. Why it is so? Because see, like living group going from one direction, one plane, from one plane, incoming coming into the another plane, that makes the difference in the configuration. So R gives S, if it is S, this S gives R configuration product. Okay, so this process, like inversion, like see, R is becoming S, S configuration becoming R. So this process is called inversion configuration. Okay, or we can say Walden inversion or umbrella inversion. See, all these groups are bending this side. Look here, all these groups there, it becoming like this now. So that is what umbrella inversion, right? So we can say inversion happens in SN2 reaction. Always remember, in SN2 reaction, inversion happens. In SN1 reaction, racemization takes place. I hope it is clear. No confusions, right? Okay, so these are the things we discussed in a single step. Now here, see, I told you single step. So in the single step, what are the things are involving? See, substrate is involving, at a time, same time, nucleophile also involving in the attacking, right? In this attacking process from the back side. So rate of reaction depends upon the concentration of substrate as well as incoming nucleophile, both. Okay, so I can say with respect to this order 1, with respect to nucleophile order 1, so therefore overall order of this reaction is 1 plus 1, that will be 2. What is the order of this reaction? For SN2 it is 2, that's why we are saying bimolecular, like this. Okay, so this is what the thing. Okay, there we haven't seen any intermediate, but only transition state or activated complex is formed, right? And here no rearrangement takes place, but in SN1 rearrangement takes place. I will show you with one example later. Just now listen here. Okay, inversion of configuration is observed. Yes, Walden inversion I told you. So this is a reactivity of alkyl halides. Okay, now what I told you, one more, attack of this incoming nucleophile is from back side, right? Oh, that's why. So this is coming from back side because of steric factors or repulsions between the incoming nucleophile and living group. Okay. Next, favored by polar aprotic. All these things we discussed already. Yes, this point is important again. Electron withdrawing group containing alkyl halides or alcohols are more reactive towards SN1 SN2 reaction. Why? Because the transition state, observe here, the transition state is having 2 negative charges here and 1 partial positive charge on the center carbon. Okay, so overall the transition state is having more electron density, like partial negative charge is more. Okay, whenever we have more electron density, if there is any electron withdrawing group is attached to the center carbon, that will increases the stability of transition state. That's why here I mentioned electron withdrawing group containing alkyl halides increases the stability of transition state, therefore rate of reaction increases for electron withdrawing group compounds, containing compounds. Okay, I will show you. Okay, energy profile diagram here we have, see, like this nucleophile, so they will forming some substrate like transition state here, finally giving product. This is a single step process. Okay, this is about the energy profile diagram of SN2. Okay, stereochemistry I told you inversion takes place like this. Okay, okay, here before going to the question, so that 8th point is there now, so let us discuss about that. For example, here I have CH3CO, CH2, CH2, Cl, like this I have, and one more option I have CH3, CH2, Cl, like this I have. So out of these two, A and B, let us say this is A, this is B. Out of these two, SN2 reaction is more favored in which process? SN2 I am asking. In which of this SN2 reaction favors? So actually tell me how the SN2 reaction happens. Let us see in this B first. Okay. So it requires one nucleophile, let us say aqueous NaOH they mention, or aqueous Ag2O they mention. Okay. So here solvent will be let us say DMSO. Okay, so they directly mention like this. They, instead of mentioning aqueous form, they will be giving like NaOH in DMSO, like this they may mention. Okay, now here this OH minus is there, that will be the nucleophile, incoming nucleophile. This chloride ion will be the leaving group. Okay, now attack of this nucleophile and removal of this chloride ion takes place simultaneously. See, this is the center carbon where reaction is taking place. I am writing here CH3, here I am writing, see, just give a minute, I just want to give you proper picture of this reaction. See, this is the CH3, I am writing here CH3 and 2 hydrogens are there, I am indicating the 2 hydrogens here. Now, see this chloride ion is going out, simultaneously OH minus is coming inside like this, right? Okay, this is what happens here, this is what transition state. Okay, so in this transition state it is having negative charge, partial negative charge. Okay, now to this carbon more negative charge is there. So in order to stabilize this carbon, we need to decrease this negative charge on this ring. So how can we decrease this? So if any electron withdrawing group is attached here or any of these carbons contains electron withdrawing group, that will decreases the electron density. This negative charge is decreased by that group, dragged by that group, and increases the stability. That's why in this both of these reactions, see here we have electron withdrawing group now, that's why A is more reactive than this B towards SN2, So you can make electron releasing groups increases rate of SN1 reaction and decreases rate of SN2 reaction. Here it is having electron releasing group, that's why its rate is decreased when we compare with this. Okay, so if it is electron releasing group, that increases the rate of SN1. Why? Because carbocation is an intermediate. In order to stabilize carbocation, we require electron releasing group. When it comes to electron withdrawing groups increases rate of SN2 reaction and decreases rate of SN1 reaction. Okay, see here it is electron withdrawing group, that's why SN2 rate is increased in this compound when we compare with this substrate. Okay, so this is relatively slower process than first option. Okay, that's why you can go with A is more than B. Okay, finally it gives the product as what? CH3 CH2 OH. This will be the product formed. Okay, you can write like this. Okay, I hope it is clear, there is no confusions here. Okay, right. Then next, yeah, tell me for this. One is label, assertion, reason. SN2 reaction of C6H5CH2Br occurs more readily than this SN1 reaction, SN2 reaction of CH3. Yeah. So what? Whether it is correct or not? So C6H5 means it should be written like this. Br. This is what? Just a normal ethyl group. Yeah. These are the things they mentioned. Okay. So they are saying reaction takes place in this more readily than this. Okay. Is it correct or not? Why the reaction? Why they are saying the reason? Partially bonded unhybridized p orbital. That is what the transition state here we will be seeing now. So transition state here, like Br minus goes out, OH minus comes in. Okay. Yeah. So develops this transition state, which is having trigonal bipyramidal transition state, is stabilized by conjugation with the phenyl ring. Yes. See, we know there is some negative charge, partial negative charge. So that will be stabilized or taken towards this phenyl ring in this. Therefore, this will be stabilizing more. Yes. Assertion is correct, reason is also correct, because that kind of stabilization is not possible here. Therefore, both are correct, and that is correct explanation also. So I can go with option 3. Both A and R are correct, and R is the correct explanation of A. 1-bromohexane. So 1-bromohexane means write like this: 1, 2, 3, 4, 5, 6. one bromohexane with aqueous NaOH. Aqueous, see this is very simple now. Aqueous NaOH they mentioned. See again this is what? Primary alkyl halide. So what does it follows? Whenever it is primary alkyl halides, they will favor SN2 over SN1. So that's why it is second order kinetics. I hope it is clear. Next, what are the differences? It is unimolecular, SN2 is bimolecular. Follows first order, follows second order. Involves 2 steps, SN1 involves 2 steps, SN2 involves single step. Depends upon concentration of substrate only, but here both substrate and nucleophile. Okay, so yeah, so SN1 as living group leaves, substrate forms carbocation intermediate. So this is have a single transition state. Here racemization takes place in optically active compound, here it is inversion takes place. All these are discussed. Okay, now whenever we have alcohol, when we are treating with HX, so remove, see alcohols are there. When acid is added, HX, remove this water and add remaining part like this. So this is a product here. Okay, now here when we have PX3, PX5, SOCl2, so what happens is this X come in the place of this alcohol. So it will be RCl will be the RCl. If it is PCl3, RCl will be the product. If it is PCl5, RCl will be the product like this. So these two reactions, this PX3, PX5 follows SN2 mechanism. Which mechanism I told you? Do not forget this SN2. So configuration becomes inversion. Okay. Now when we are taking this SOCl2 or SOBr2, it follows in intramolecular nucleophilic substitution reaction, that is what? SNI. So the product configuration will be retention product. Retention you can write. So here when we are taking with pyridine, it will be again inversion. So what is this retention inversion? I already explained. For your clarity, I will be explaining here one more example. Like this, see like this we have a question where it is included OH like this. Okay, now this is a chiral center. Like check once, all these 4 atoms attached around this highlighted carbon are like different. Therefore, I can say that is chiral carbon. Now, when I take PCl3, okay, we need to take, when we are treating with PCl3, we need to take these 3 moles. Therefore, 3 moles of product is formed. So the product will be like this. What mechanism I told you? SN2 now. So inversion of configuration. This is above the plane. What is this? This is above the plane bond representation. So wedge line notation will be there now. So this is above the plane. So it will be inversion means it should be below the plane with Cl. Okay. So here byproduct formed is H3PO3. Okay. Like this, if we take this is 3 moles with 1 mole of PCl3, we will get 3 moles of product and 1 mole of this byproduct. Okay. When it is PCl5, same product will be formed and byproduct will be POCl3. Okay, configuration is similar to this. Okay, when we are taking SOCl2 in pyridine, here also I told you inversion of configuration with the SNI mechanism. Okay, and this is also inversion means this is also product is similar to this. But when we take thionyl chloride, simple SOCl2 is taken. Okay, here it is retention product. We will be having configuration same as a reactant, like Cl will be same as like this. It is above the plane, here also above the plane. Like this you need to understand. This is also very important. Write this. Okay, take a screenshot otherwise. What are the byproducts here? It will be SO2 and HCl gases. So these are easy to remove. Therefore, preparation of alkyl halides from alcohols will be more preferred or more useful by this method. SOCl2 is used. Okay. Then next we have here, tell me, this is ethers. See, this side is alkyl group, this side is aryl group. When it's treated with acid, Hi is stronger acid. Hi is stronger acid than HBr, which is stronger than HCl. So Hi is stronger acid. Now we need to add, it will be giving H place, okay, HI release a H plus, source of H plus. So now this lone pair electrons of oxygen will take this H plus and forms a like a positive charge species like this, right? Now we have I minus from HI, because H is given, remaining I is there, I minus, and it is heating. Now we need to, the breaking of this molecule takes place because oxygen is having positive charge. Now oxygen drags the electrons from here as well as here, but you tell me where it will be more easier to break the bond. See, if I break this bond, we will be getting a carbocation like this. This is secondary carbocation, right? But if I break the carbocation this side, I mean generate a carbocation this side, it will be what? It will be a phenyl carbocation, which is highly unstable. So you should not get this because it is highly unstable. So therefore breakage always takes place this aliphatic side, not towards this aromatic ring side, okay? So you should not break this side, okay? So remove this and we will be getting like this. When we are getting a carbocation like this, so what is the remaining part here we have? That is like this and attached with the O and also H, okay, like this. So now this iodide ion will attack on this carbocation, will be finally resulting to form like this. This is the product. So cyclohexyl iodide, this iodide and phenol. See, phenol is obtained. So this is how you need to identify, okay? I hope it is clear, there is no confusion, okay? Now look here, what kind of mechanism it is following, SN1 or SN2. This is also we need to highlight this. See, OH minus, like oxygen is removed, this negative part is removed from here now. So it means removed and I minus came into the place of this. So it is substitution only now. Negative part substitution is what? Nucleophilic substitution. So which substitution it is? SN1 or SN2. So in acidic medium it is SN1. So this process happened from SN1 mechanism, okay? Option B is correct. Mechanism, if they ask SN1 you should say. Next, you tell me for this, consider above chemical reaction product A is, what is this product A they are asking. See, NaOH is given, so how can we identify? See, this is alkyl group present at secondary carbon, right? Secondary carbon, okay? Now, yeah, so now tell me, this is NaOH and we know water. Water is polar protic solvent. So whenever we are having secondary alkyl halides, so most of us might be having some confusion like whether it is SN1 or SN2. So that time you need to focus on what type of solvent they mention. So water, I told you this is polar protic solvent. Now what happens? It will be favored by SN1 mechanism. Polar protic solvent favors SN1. Therefore you can take this, you can take this molecule here. I just want to confirm whether everything is visible properly or not. Yeah, so you can take this like this. What happens in polar protic solvent SN1? This will be polarizes, right? Like here we will be getting a carbocation like this and chloride ion will be like separated from here. So this carbocation is secondary carbocation. Here we have one hydrogen. So carbocation rearrangement happens here from here to here and we will be getting a more stable carbocation like this. See? So when it is shifting here, we will be getting a hydrogen here. See, hydride ion shift completely, this is shifted here along with the bond. So we are getting a positive charge on this carbon. So this is what? Tertiary carbocation, right? So on this tertiary carbocation, here we have OH minus, right? That is what the nucleophile here. That nucleophile will attacks on this carbocation like this. And finally, we will be having a product like this. So this is a final product. I hope it is clear. There is no confusion in this explanation, right? Okay, next let's move forward. So what is our major product? So this is our major product A. I haven't shown you the options, I directly explained by taking the question itself. So this is a JEE mains question. Okay, now tell me, reactivity of alkyl bromides, which is more reactive? Towards iodide ion in dry acetone, towards iodide ion, I minus in dry acetone. Yes, dry acetone means what? So this is purely solvent effect. Dry acetone means there is no water, only acetone is there. So we know acetone nature of the solvent is what? Polar aprotic. So if it is polar aprotic, favors SN2 mechanism. So SN2 mechanism is more readily takes place in 4, then next in this is because methyl bromide, like we know SN2 reaction takes more easily in methyl halides, like alkyl halides, I mean primary one, like methyl halide, then next primary alkyl halide, then next secondary, and least in tertiary. It means this is a methyl bromide, easily reaction takes place. So 4 is first more reactive, then next 1, 4, 1. So 4, 1, we have any option? Yeah, 4, 1. Then next secondary, this is 2, 3. So this is least, na? So option 1 is correct. I hope this is very clear. See, this is asked in EAPCET exam, but quality of question is very good because we need to get that strike. It should strike in our mind that what is the important criteria we should consider here in order to answer this. So it is purely what? Depending upon the solvent effect. Okay, that kind of approach you should get during the question. Okay, like what is the main factor we should consider here. So by solving more number of questions, so you will get clarity, you will get the clarity on this kind of questions. Okay, now tell me, which of the following will be most reactive for SN1 reaction? Yes, already discussed it na. It is resulting more stable carbocation, so D is more, I told you. This one, Williamson ether synthesis. Williamson ether synthesis from alkyl halides. For example, here alkyl chloride is there. So for this we need to take ether synthesis na. So which means ethers is having ROR formula. It means this is the ether. We have R part, we need R like remaining OR part. So it means alkoxide ion is the nucleophile with some salt, ethoxide and sodium ethoxide ion, potassium ethoxide ion, something like this will be there. So this is the living group, like halides will be the living group. So this will go and attack there. So in basic medium you can go with SN2 mechanism. In acidic medium mostly it will favors formation of carbocation, which is SN1 mechanism. So this is what happens in basic medium in non-polar solvent, I mean polar aprotic solvent. So this is what Williamson ether synthesis is what? It follows SN2 mechanism. Okay, so in SN2 mechanism what they are asking? Decreasing order of reactivity of following compounds. Yes, tell me. We know primary alkyl halides are more reactive towards SN1. So identify which is primary here. Yes, this is primary, this is also primary, and this is allylic primary. So whenever we have allylic and benzylic are there, so these will be highly reactive, they show highly interest towards SN1 and SN2, because whether formation of intermediate in carbocation in SN1 will be stabilized by that allylic pi electrons by delocalization, and even in the transition state also they will stabilize the transition trigonal bipyramidal geometry transition compound activated complex. That's why allylic and benzylic halides are more reactive towards SN1 SN2 reactions, whereas whereas vinylic and arylic, it means vinylic means like this vinylic and aryl, directly halogen attached on the benzene ring. So these won't involve in SN type reaction, they won't involve in SN1 and SN2 reactions. Okay, now this is primary and allylic, so 2 is more reactive, then 3, and remaining this is what? This is also primary, but bulky group is there here, therefore this is relatively less reactive than this, and here it is also primary, but here also very large bulky group is there. So as a chain or steric factor is increasing, SN2 reaction decreases. Williamson ether synthesis follows SN2 mechanism. So therefore least reactivity is for 1. So I am writing least is for 1 and here I am writing fourth one. Yes. So just identify the option 2, 3, 4, 1. Yes, option D is the correct. Okay, next correct order of following alkyl halides for SN2 mechanism. Yes, easy again. Just whatever we discussed in the previous question apply here. So take this as a homework. Hashtag question number 1 answer to this question in the comment box by mentioning this number. I will check whether you are able to follow the class or how much extent you have understand this. Very basic, very basic. SN2 they are saying which alkyl halide will be more reactive. You should think and answer that. Nothing to think, directly you can give the answer. Now here also arrange the following in the correct order towards SN2. Same question. Yes. So chloropropane to chloropropane. Yes. So you can also same whatever we discuss similar to that like living group ability and size. I mean size factor like steric factor you should consider here also. Next. Here least reactive towards reactive alkyl halides towards SN2. Least reactive again same concept chlorobutane 1 chlorobutane, this is the 1 chlorobutane, this is what size same again, this all three questions are almost same. See it is increasing the number 1 chloro 2 methyl propane. So bulkiness is increasing now here like that, therefore reactivity what happens, size branches increases. You can write this statement for this hashtag branches increases SN2 rate decreases, rate of SN2 rate decreases. You can from this you can answer this question. You can take hashtag question number 2 and write in the comment box. Next. Yes, PBr3 is there with alcohol. So what happens, I told you to change this into Br here, right? So this is what happens here. Like alkaline KOH is there, that is for elimination purpose. So here CH3 group also there, elimination reaction. So remove this and we will be getting a pi bond here. For about elimination we will discuss again if you want. Okay, so now the option will be, this is option A, this is option B. Yes, I mean option 2 is correct. Okay, now try this question. I told you whenever we have HI, it gives H plus and add this H plus to alcohol oxygen and break this bond in such a way it should give relatively more stable carbocation. So if we break here, phenyl carbocation is highly unstable, so you should not break this side. Okay, but you can break here, therefore we will be getting a benzyl carbocation which is stabilized by resonance. So we can get like this part as it is, you write phenol we are getting, B is phenol, and what about A? So that is CH2 and I minus you can add on the CH2 plus will be giving this one. So what are the options? This one, option 2. Like this you can answer. Okay. Yeah, so take this hashtag question number 3 again. Anisole, what is the anisole formula? On benzene ring we have OCH3 group. So how can this cleavage takes place? What is the cleavage of this bond in presence of OH, HI minus, like HI. So HI. So what is the kind of products it is forming? Same story, whatever I explained to the previous question you can try. So give the answer for this with hashtag question number 3. Next, see anhydrous ZnCl2 and HCl, like concentrated HCl and anhydrous ZnCl2 is called Lucas reagent. So this Lucas reagent is used for conversion of alcohols to alkyl chlorides. Okay. Now tertiary alkyl chloride is more reactive. Alkyl halide alcohols, tertiary alcohols are more reactive then secondary, then primary. So these tertiary alcohols shows the reaction within 2 to 3 seconds, like turbidity is formed within 2 to 3 seconds, but this requires minutes and this requires lot of time. Okay, therefore what is the reactivity order? Here we have tertiary alcohol that will be more reactive. Okay, which of the following reaction can be used for preparation of alkyl halides? Okay, but here there is no, but here, yeah, So but here there is no Lucas reagent. See here we have Lucas reagent, anhydrous ZnCl2 and HCl. Yes, this process happens. So fourth option here we have, and the next we have, yes, fourth option here we have, and the next here also we have anhydrous ZnCl2. This is primary alcohol. Reaction happens but it is slow. This is also possible. This is also possible with Lucas reagent. And out of these two, this is primary alcohol. Without anhydrous ZnCl2, this process won't take. This is what the difference you need to understand from here. HCl is there, that is fine. For producing H plus it is there, but ZnCl2 is required in order to, as a catalyst, in order to faster, in order to make this reaction to happen. So but no ZnCl2, so no process, no forward reaction. So you remove this. So this is happens because tertiary alcohols easily dehydrated to form more stable carbocation. So this is correct. So 134 option 4. Yes, which are the following alcohols reacts instantaneously? Yes, fast reaction with tertiary alcohol. Just now I told you. Yeah, what is the sequence of bond? See, I told you this is 2p, same size. So strong bond, more bond enthalpy for CF, then CCl, then so like this. Okay, if they ask reactivity order, exactly opposite, like this. Reactivity is like this towards nucleophilic substitutions, whether SN1 or SN2, which does not undergo hydrolysis. So which will not show hydrolysis, means addition of water should be made for this. So it should remove this chloride ion, replace with water. In which process it is easy they are asking. It will not be possible in which process they are asking. Benzyl chlorides takes place, tertiary alkyl halides takes place, allylic chlorides takes place. But when it comes to vinylic and arylic, I told you there is no involvement because this chlorine atom already in conjugation with this pi electrons. It is having less tendency to go out, of this like this part. It means this is very stable. Vinyl halides are very stabilized by this conjugation, so they won't involve in SN1 SN2 reaction, so it will not undergo hydrolysis. So option D is correct for this. Okay, so now SN1 fast test in which process? Yes, this is hashtag question number 5 you can take and answer this question. So SN1 more readily takes place in tertiary alkyl halide, that's it. So you can answer based on that. I hope this session is highly helpful. I have covered almost some 25 to 30 questions. It includes JEE questions, NEET questions, EAPCET questions. So whatever exam you are going to attempt, session will be highly helpful. If you feel really confident, so write in the comment box about this session, and you can also share with your friends. Okay, and if you are really facing any difficulties in any of the other topics, you write the topic in the comment box. We will be focusing on those topics also for upcoming exams. So thank you for watching. Happy learning.